Hi there. Today I'm going to try changing out a switch on my Ultrasabers. I'm going to start here with my Bane. I plan on putting in the little 12mm AV switch. I like to thread these into there instead of using other methods of mounting it. In order to do that, I'm going to need to use this little momentary to latching switching circuit. I got that from the custom saber shop, and that's really all there is as far as background. That will be lighted, so I've got a little resistor here that I got off of Amazon. This resistor is actually a little higher power than I need, a little more ohms, more resistance, but it's safe to use and it will light my switch still. In fact, I've actually tested it already using this little button cell battery that I keep down here just for testing these LEDs. And all you have to do with that is touch the positive and negatives of your switch with the button. Typically, you see, you get it to light up there. Doing it for a very short time, this doesn't put out enough current to hurt anything. Potentially could in the long run, but not for very quick. Also, I'm not rewiring the battery pack on my Ultrasaber, so I'm going to be running 6 volts, which is why this will be better, whereas it's been tested with 3 volts as that battery puts out. So the first step I need to do is to get this black push button guarded switch out. And then Ultrasabers just drills out a flat hole and presses these buttons in to fit. So you have to pull them out. Now on the Bane, it's not recessed really because it has that skinny neck section there. So I hadn't tried this before, but I just now grabbed it, and there it is. First attempt. So actually slightly easier than I was planning on it being. Usually I have to grip it with some pliers because it's down in a recess and get some grip. I don't like to pry on them because it tends to score up the area around the buttonhole. And for the most part, I want to reuse that area. So we can go ahead and cut off the heat shrink here. I could just snip these off if I want to, and I may do that after a minute because of the way Ultrasabers does their wiring. But for now, I'm going to peel them and see what I've got up there and show you what's in there. Yeah. And I just make a little score in the heat shrink. I don't typically push all the way through because if I'm going to reuse any of the wire, I don't want to cut off all my insulation. Although it really wouldn't matter because, as I say, there's a lot of wire here. I could cut that shorter. You can see here Ultrasabers has a joint down here where they've connected this together. I might actually go ahead and just cut that out and use a whole new section of wire up to my strip. This will be where it connects to the battery pack. On the other side of this will go straight to the LED, and then coming down the back side from the LED, it'll have the ground wire and the resistor to operate the LED safely. So I've got that out. This part doesn't matter, but I'm going to take my blade out. That's just basic blade removal. And then for this, because I want maximum workspace and because of the way the Bane is assembled, I'm going to go ahead and take my emitter off. Now the emitter, I take it off on most sabers. Most of them MHS screw in. Ultrasabers usually are familiar with that. Bane's a little different. It has a retention screw in the back that keeps it tight and snug, while this little greebly screw actually goes all the way through, and it does contact on the blade if you put it all the way in to help retain it, but that actually helps hold this into the body, so your emitter just sets in on the Bane. Now from there, give it a little shake, and there's my LED unit. And I've got a violet amethyst LED in there, so that's why I have a resistor up here. This is going to be, there's going to be another resistor down here in the main line that protects both LEDs. Let's see if I can get it up here. Oops. My switch wire is making contacts here. Hadn't planned on this part. There's the other resistor. That one gets our voltage down from 7.4, 6 to 7.4, depending on which battery setup is in your particular Ultrasaber, down to the 3 volts typically required by the LEDs. And then this one over here is, I'm sure, I haven't opened it up, but I'll guarantee this one's for the red side, because the red side generally runs close to 2.5 volts. So this is going to bring it down, allowing the blue to stay at 3, red to run at 2.5 safely with the 6-volt battery system that's in it. Now, going to back up here to my switch. What happens with Ultrasaber switches, they put their wire on and they give it a little twist. They loop it around the end of the button, give it a little twist, and then solder it up. So I have no need for this little bit of wire that's on here. And as I said, in fact, I'm probably going to end up cutting this, because I do need to get these parts a little more out. I'm going to open up my my end over here. Now this Saber has a pretty smooth interior because this one has their MLS unit. This is the modular lighting system, LED housing from Ultrasabers. And what will happen here once I've taken this switch off, which, as I said, I don't need those little loops of wire there at the end. It'll just, I'm just going to snip it out of here. So there's the switch. Now that I've got that, I can pull these wires out a little further. Because what will happen with an MLS Saber body, it's pretty smooth bore, and I can pull the whole battery pack and everything completely out of the Saber. There is now nothing in this body. The Sabers with a 1-inch body, battery pack typically has to go out the other end, but in most of those, the LED unit will slide clean through. So one way or the other, once the switch is removed, you can pull everything out. I'm just going to set that body aside. So here is the basics of my wiring. Things I do need to keep: the battery pack, this resistor, because I will be using the same battery pack, this resistor to protect the LEDs, and of course my power leads. And that's going to all go to the new switch, but in order to get to the new switch, it's going to go through this little circuit card. So the length of wiring I'm going to need from each end is going to change, because I want my little card accessible down here where my battery pack is. In fact, once all the wiring connections are made, I will probably glue it to my battery pack, either here on the side or the top. We'll see. It just needs to be secured in there somehow. So, to do this, to start off, if we take a close look at the card here, it tells us all of our connections that are needed. It's a little hard to get the right lighting on the camera and get the right focus. Let's see if I can get it to see this. There it is. So I'm going to need these 2 switch connections over here. I'm going to need a ground connection, and I'll actually end up using 2 of the ground connections because I'm going to wire my switch light to 1. I'm going to need the volts out. These are going to go to my switch and to my main LEDs. And then I'm going to need these volts in over here, as well as one of these grounds, to get my voltage into the circuit card to be relayed up to the lights. Now there is a little test switch on here. Oops. There we go. there's a little test switch over here. So once I get the power hooked up and the lights connected first, I'll be able to push that and make sure that the card works. Okay, before I get on with the wiring, I'll go back to the body. Now this hole, as I said, was a press fit. This switch I want to thread in. You can see the bottom of the threads, the base of the switch, right there at the threads, kind of sets on top of that hole. So what I have to do for my first step to getting this thing to thread in there nicely is to take out a tap. Take out a tap, and I'm going to widen that hole out and tap it. Now the tap can be done straight from here. The hole is just big enough, but it can be kind of difficult, especially with the thicker saber bodies. So I'm going to actually take this body to my drill press, which is already set up. This tap is, let's see the markings on it. This tap is an M12 by 0.75. That is the correct thread for the switches that come from the custom saber shop. And to confirm that for myself before I start cutting on stuff, make sure I've grabbed the right one and everything, I usually take the nut off the switch and thread it on my tap. If it goes that far down, that smoothly with almost no resistance, you got the right size. Get that back off of there. That in here. Now, let's see here. I'm trying to get this over here where you can see my drill press set up. Right there. Now I've already got, this is a 1/2 inch drill bit. It's which actually leads it out to being a 11.5 millimeter is the matchup. I'm going to set my saber in here. Not everybody has a setup like this. You don't need it. As I said, that tap will work in there the way it is, or you can, there's all kinds of ways you can hold this and drill it. I happen to have this set up because I do a lot more tinkering. So it just, I'm going to go ahead and use it. I'm getting everything lined up here as precisely as I can before I start anything. This is an expensive setup if anybody really wants to get into saber tinkering. This whole thing came from Harbor Freight, cheap drill press. I think it was about $250, even for this tall stand-up model. The device thing I think was about $70. Alright, I got everything aligned as far as I want it. I'm going to go ahead and drill this out. And that's it for that. Doesn't take much. There we go. Just barely enlarge the hole. Now, come back over here. This part can be a little more taxing. Takes patience. Gotta hold everything nice and straight. If you haven't worked the tap before, just make sure you're holding it straight from all directions. It's got to be straight up and down with your hole, and straight this direction with your hole, and just slowly take your time and get it turning. The taps sometimes need to be lubricated in some metals. In these aluminum saber bodies, that can actually overdo it and make them cut too fast. You want to be careful about adding any kind of cutting oil or anything in when you're doing it in these saber bodies. It can just really let you overdo it. And now you can see I've already, see how easy this is spinning now. I've already cut my threads. This is done. Okay, I give it a few more spins just to do, but this is done. And then Turn it back out carefully again, because if you go too fast and you start canting things off to the side, you can ruin it from here even. A lot harder to do once it's started and done. But there we go. Now I can't really show you the threads. There's not much in there to see. The camera's not going to see it. This is a fairly thin saber hilt. That's why it cuts so easy. But now you can see I twist my switch in there. It sets in there really nice. Just right. Okay. So we're going to back out of here. Back out of here for a minute. And now I have a trim ring that I'm going to put on this switch when it's time. So I'm going to pause the video real quick and find that. I'm back. Okay, here's the trim ring. This is from the Custom Saber shop. Again, it's hard to get the camera to focus on those little things while I'm here. Custom Saber shop's been out of the larger trim ring for the 16mm switches for a little bit and for the MHS V1. However, this being the Bane, has a smaller little section here than the outside, which is actually an almost perfect match for the MHS V1 or V2 size at the Custom Saber shop. So this trim ring fits here with just very little gap around the front and back edges. Okay, so that'll work perfectly for what I'm attempting to do today. Now, I'm going to go ahead and start the wiring on my switch. In order to do this, I'm going to use some very fine wires. You don't need anything big for this switch. The switch is controlling this circuit. The circuit's doing most of the work. The LED in there takes a very low current, 20 milliamps. That's really not much. I'm going to go ahead and use some 30 gauge wire that I got from Amazon, and I'm going to use a bit of red and a bit of black for the power leads and the power for my LED on the switch, and then I'm going to use just another color to get to the switch so that I don't get it confused with anything else that's in there, because the switch isn't necessarily a ground. It just has to get current from one side to the other and connect these two contacts on the board that were marked with the little switch light. Yeah. So now to make sure everything is the right length, I am actually going to do a little trick here. Yeah. So just going to pull out enough wire that I know it'll reach from my switch, or from my switch out the end of the saber. I want it to go out a couple inches just so I'll be able to lower the battery pack out, get work done when I want. This saber has lots of space up inside, so I'm not too worried about that. So I'm going to go ahead and cut off, I don't know, about 8 or 10 inches, just holding it from the switch to the end of the saber. Tells me as much as I need to know. I may waste a little bit of wire. I may want to cut some off later. The wire's not that expensive, I don't care. It's pretty common to have a lot of little scraps done left over after doing a project like this. So if you're super conservative, you may have a hard time with it at first, but you can get used to them. Alright, this is my power and my ground wires for the switch's LED. I'm going to lay them aside. Bane's got to cut out, doesn't sit good on that end. I think I'm just going to go ahead and use some blue to do my actual switch button, just because that's what's in here. Sometimes I'll run colored wires to my LED's power to let me know which LED I'm working with when I'm doing RGB sabers. That's the reason I have so many colors, but it really doesn't matter. Color does nothing except let you or whoever else works on your saber know what it is. I'm taking this video, if you can't tell, from a very beginner standpoint. Very basics. Now, one thing I am going to do from here before I go any further is I'm going to add this resistor onto my LED first. And with a resistor, it does not matter. People all have their preferences. It does not matter if it's on the positive side or the negative side. Doesn't matter if it's in the power or the ground. It just has to be in there. You hit that button, light travels through, or electricity travels through there at basically the speed of light. Whole thing gets powered up at once. The whole thing starts taking the same amount of resistance at once. There is flow in theory and diagrams and all that stuff, and if you have a diode in there, it might have you start to make a difference in the overall circuit. But for what we're doing, resistors have nothing to do with it. It can go either side. The little pins on here are negative, or are marked. There's a positive, a negative, and then two that just are 3 volt, whatever. It doesn't say. It doesn't have any designation, positive or negative. So the ones that are marked positive and negative are for your LED, and that will always be the case. The ones that have no markings, that may say normally open NO or NC for normally closed, or some combination thereof, those will be your actual switch. When you push it, that's what activates. So I'm going to go ahead and I'm going to put this resistor on the ground side of it. As I said, it does not matter, but that's just the way I've decided to do it with this particular one. And I'm going to put my wire up in here. I'm going to kind of do like Ultrasabers does and bend this wire up around the foot a little bit. Twist it over and make a little loop. And then I'm going to pinch that shut tighter than I can get it with my fingers. Doesn't matter the solder when you're done makes the connection ultimately. So the wire just has to be in contact with that switch so that the solder can hold it on there. Is all you have to do right here. Okay, so that's there. I'm going to put the switch into a clip here that'll hold it for me. Turn this so y'all can see. I'm not used to doing this on video. I'm a little clumsy at it probably. There we go. There's the switch and my stand with my resistor on there. Grab my iron. I'll make sure my tip is pretty clean. I haven't done that yet. This is a wet sponge. A little bit of dampness. It keeps the you can rub the oxidation back off the tip of your soldering iron so that it works a little better. So I'm going to take this, keep my resistor as straight as I can, get a little heat contact up in here, add some solder on here. There we go. Get that solder to bleed in through the wire and hold in. Pull the soldering iron out. Let it set for a minute. There we go. It's connected. Alright. Now, that's connected good. I'm going to go ahead and just trim off the excess wire lead carefully. And there we have our resistor in place, ready to go. So then I'm going to turn this over. And I'm going to go ahead and attach my red wire, my voltage in, to my LED on the switch. Short clip there. These ones, when it's just a wire connection, I don't tend to wrap it around up in there and everything else. It can. Some say it makes it a little stronger. I've never had a saber come apart for me at the connection before. The twisting and the bending of the wire around everything, to me, seems as though it leaves it kind of, like when you bend a wire too much and it gets fragile. Again, that's just personal preference. I've not had one come undone. I like to just stick the wire in the hole here and then add my solder. And there we go. That one's on there. That's all it took. A couple seconds. If it takes more than a couple of seconds, you probably need to relook at the heat or anything else on your solder. because you don't want it to take long. The longer you're on there, the more chance you run at risking damage to the plastic or the switch itself. Same thing with any circuit. You can see, give it a little tug, doesn't go anywhere, no problem. That one's ready to go. And I'll set the switch down here, and I'm going to grab my my ground wire for that switch. And now this, I'm going to cut this a little bit more of an end than what I did on the other ones. Okay, give me a little more exposed wire, because the way I do these ones with these resistors, and this is something that I started doing because for a time I was using these variable resistors from the Custom Saber shop. These work great. You don't want to do any calculations. They're 20 milliamps. They'll power just about any of these little accent lights you want to correctly over a wide range of voltages. You overheat them, the legs come off super easy. So what I started doing with these resistor legs is I take my resistor leg and I just twist my wire around it into a nice tight coil. Okay, so it's going to connect easy, and then I slide it down against the resistor, and that just basically puts me in place to have it go pretty quick once I try to apply the solder. I put these ones right up against the resistor. They're a little more heat tolerant. A regular resistor is a little more heat tolerant than that variable resistor, but I still want to get in here fairly quick, coat my wire, pull my soldering iron out, give it a second to cool. It only takes a second, and boom, there we go. We have our connection on that switch. Now I'm going to go ahead and trim off the excess from the switch, and then I dropped some pliers. Give me just a wire cutter. I'll be back in just a moment. Alright, I'm back. Got my pliers, or my cutters. Now, one thing I like to do at this point, just because, is if I open up a little bit of this other end here on those wires, just a little. I don't need it where the wire's going to fray all over and be getting in the way. But then I can push each end of these two wires now up against my button cell battery, and see my switch does indeed light up. Doesn't hurt to sit there and hold it for a while now because the resistor's in, safe. There we go. Working switch. I'm going to trim up. I got just a little bit of excess around one of the wire tips over here. And trim off just to keep it a less pointed, because I am going to put, there we go, there. Now I'm going to cut a little bit of heat shrink wrap, heat wrap, whatever people want to call it. It's got several different viable names. As long as you know what you're referring to and what you're doing with it, it's fine. Got some black one here. This stuff, I had an electronics store here in town that was real nice to go get this stuff at. They went out of business. I didn't expect them to last too long based on what inventory they had and how many of us hobby builders are still around. But now I just get this at the automotive store. The kit comes with a lot more options than I really need, but it's got what I need in it also. These little tiny resistors are small enough that I can slide that wrap right down over the resistor. Come on. If I can get this to focus, I can slide it down over the resistor. Some people put the wrap over the top of the resistor, and that's fine in general. Part of what a resistor does to a certain extent is to dissipate some of the heat of the circuit. So I like to leave the resistor exposed to the air around it when it's operating. So even inside the Saber, which is fairly closed, there is some air circulation. So I like to wrap my resistor ends, each end individually. Again, that's another personal preference. Doesn't matter which way you decide to do it. Wrapping over the resistor or wrapping around the resistor, both are viable. But there we go. And then I got another piece from my ground lead over here. just a little heat and that shrinks right up on there, tightens down. Only need a little bit of this stuff, just enough to hold it in place kind of and protect. And see, we'll see if I can get it to focus on here. Might be too close. Well, anyway, go ahead. Here we go. It just shrinks right down on there. Grabs the wire, grabs the solder, provides insulation and a little strength. And there we go. All right. Now, the next step is my contacts leads, which again, these are going to be attached to the. They're normally open because it's a momentary switch, but these are going to be attached to those other two prongs that don't have a positive or negative marking. I'm going to have two of them, so I'm going to go ahead and prep them now. And set this in my little helping hands. These helping hands clips here, these are super nice for working on this kind of stuff. They can they really let you work easier. You put your wire there, you put your wire in the hole, you put your wire in the other clip, and all of a sudden everything's lined up and things just aren't falling apart all over at you. So sometimes I gotta fine tune my adjustment just because I decide I want to do things differently. This one I decided I wanted the wire from the inside to the outside of the switch hole, and that's not the way I put it the first time. So that's where it is right now. The wire's going through the hole from the inside to the outside. I've got it sitting there fairly stable. I'm gonna grab my solder, grab my soldering iron, apply some heat, apply my solder, pull it out, let it cool, unclip my switch, unclip my wire, and it's on there. Very simple. And we'll go ahead and do the other side, and from there, after doing that side, I'll heat wrap those two, just because any connection that's inside there, I like to have it covered in plastic, rubber, you know, just some material, insulating material, so that it can't cause a short or anything like that at any given time. A short in electricity just means that your electricity is taking a shorter route than it was intended to, and it's making contact somewhere it wasn't supposed to. This can cause various problems or no problems depending on the actual circuit. Alright, now I got that there. Need to apply some heat, apply some solder, pull it out, let it cool, unclip my wire, unclip my switch, and there we are again. So my switch is now wired. I like the look of those connections. I'm going to go ahead and do my heat shrink wrapping on there. Just keep everything nice and safe and secure. And then, let's see here. Push that down. You want to push this down over the leg of the switch. Now, because I'm using very fine wire, I'm using the smallest heat shrink that I've got. So sometimes just getting it started over the end of the contact there takes a second. A little bit of patience. Everything you do in this kind of thing takes a little bit of patience. This is one of the reasons this is one of my hobbies. It helps to keep me calm and settled. Working on things that are inherently frustrating seems to take all of the rage monster out of me that I used to have. And again, a little bit of heat, and they tighten right up. You want to leave the heat in one spot too long. I've got my heat gun turned down. I only keep it at 350, probably not enough to mess up with my solder or anything like that, but it's plenty to harm that plastic up in the switch if I take it on too long. So now I have my switch fully wired up, and this comes the fun part. To take these leads and kind of turn them all together in some which way. This particular wire doesn't twist together and stay that way particularly well. It's got the what is it, pt.1 coating or something. It's basically Teflon coated. The outside housing on it. There we go. And you feed your wires into your saber. I'm putting everything down. As I said, I want to put my switch close to my latching card close to my battery pack, so I'm feeding everything down right out the bottom of the saber. I'm going to go ahead and hold this here. Now, as I twist the switch in, you can see the wires, they just kind of rotate around in there. And as long as they're rotating, that means everything's kind of coming free inside. It's just spinning like a universal joint on a tool would, basically. It's as it goes around instead of tangling up. It's really hard to keep the light going there. There we go. You see how it's going now. As it starts to pull back up in, you want to hold the switch and just kind of look in there and pull it out straight, because what's starting to happen at that point, if it happens at all, is that you're starting to get the wires to wrap around the switch connectors instead of just rolling freely in there through it. Now it gets a little difficult getting in there when you get close. There's not much to grip on these switches, and this little bezel ring, trim ring, bezel ring, they can add to the challenge of it. Because oops, there we go, I just pulled my wires in. Okay, so get them back out and twist. This little bezel ring starts to get to the point where it wants to grip with the switch instead of the saber. Now I got my switch basically locked down against the bezel ring, not completely. I haven't locked it in place yet with any kind of force, but you can see what happens is my bezel ring is turned sideways. So I got to kind of kick that back and put a little pressure on it with thumbnail, hopefully is enough, and still try to turn this switch in. And for those that don't have them, fingernails help a little bit here. That's what I'm using for my primary grip ability at the moment. There's other ways, obviously. Any way you can grip it, you can. If you can hold that bezel down in place, just putting pressure on top of that switch is often enough to grip it for a good part of it. Now the problem that starts to run into